All right, we're back as previously stated. Circuits have three parts: have batteries, continuous conductors that go from the positive terminal to the negative terminal of the battery, and then out to and then through a light bulb or some other device that converts energy. So you put energy into a circuit, and then you will get energy out. The rate at which energy is transformed or transferred is referred to as power, or electrical power in the case of charges moving. So power is defined as how much work is done per unit time, or how many joules are consumed or transformed every second. And if we look at the electrical definition of work, as previously stated, would be Q times delta V from our potential chapter. So QV will do it. And if we look at QV, this will carry units of coulombs times joules per coulomb. So Q are coulombs, charge is coulomb, and potential difference are joules per coulomb, or voltage. So we end up with units of joules. If we do QV divided by T, we get the powers work over time. Q over T is I. So electrical power can be computed by taking the product of the current, I, times the potential difference, V, voltage. If you increase the current, you'll increase the power output. If you increase the voltage, again, you'll increase the power output. You'll get more energy out every second. So another way to think about electrical power is the rate at which energy is transformed. If we have a pipe with water flowing, you can connect a generator to this, and the rate at which this spins is, the water wheel spins, is related to the electrical power. So the water at the top has GPE, gravitational potential energy. It gets transformed into KE. As the water falls, it loses gravitational potential energy. The wheel turns and the water falls, doing work. Electrical circuits are similar. As charge falls from a high potential to a low potential, from a high to a low, energy is transformed, and we can use this to run a light bulb, a motor, and so on. What is the unit of power? That's the question exactly. It's actually joules per second, which are watts. Can we rewrite electrical power using Ohm's law? Power is I times V, so here's the first equation. Given Ohm's law, I equals V over R. If we put in V over R where I was, we get power is V times V over R. So power is V squared over R. So let's just circle the many ways we can define it. The first one is I times V. The second one is V squared over R. And then the third one, again using power is I times V and V is I times R. So we'll get power is I times R, I squared R. So we end up having it our way. There are three different ways we can define electrical power. I'm going to write them quickly, and then we'll come back and paste this into memory for later use. Power is I times V, is I squared times R, is V squared over R. So I'm going to take and paste this into memory. Let's just highlight the whole thing. Copy it, whoops, and we'll pull that back out soon enough. Batteries are sources of energy or sources of power, and as previously stated, DC, AAA, AA all have a potential difference of 1.5 volts, and 9 volts have a difference of 9 volts. So in theory, the 9 volt could produce more energy every second because you'd have charge falling through a greater potential difference or being